Hey everyone, I'm waking up Mubot here so he can be in the chat and help moderate. Who's in the chat? Is anyone here right now? There's some new ways to play Kahoot called, there's one called Robot Run. And I will say this, there's one question in the Kahoot that we didn't, I don't think I told you yet, but it's all right. It's all right. It's more of a general question. If we get to it, we'll get to it. It's a question that's not on your test, but I could change it. But it's fun to see. Maybe I should change it, right? Let me change it. Let me go back here. But how's everyone doing as I do a little setup right here? I can't go back. I can if I go over here. So let's see. There's one question I was like, we didn't cover that. Edit the Kahoot. Edit the Kahoot. Where was it? Okay. Which of the following describes residual? Anyone in the chat yet? Anybody? Say hey if you're in the chat, and then we'll start the Kahoot. We gotta have people here to play Kahoot. Gotta have people in the chat. Yes, sir. Straight out of 320. Nice to see you, William. I'm changing a question here. Okay. Well, we have it. I throw a $20 gift card to the winner. $20 Amazon or Starbucks. So you might, if you're the only person, you'll win. Let's see here. Let's go to host live. Let me bring the Kahoot to the main screen. Okay. We're going back to our 201 island. Let's go to the main screen. Let's do this. Okay, there's Robot Run now. I kind of wanted to do that, but we'll do regular old Kahoot. Let's try classic mode Kahoot. So we got it loaded up. So you can go ahead and click the Kahoot button right here. Join in the Kahoot. I'll be dropping some hints here, how to study for the test, how to understand the materials for the test, and what to do on the test. So please, please, please check this out. You might be watching this in the future. It's got the computer audio going. It's got the nice little Kahoot music in the background right there. Oh no, I can hear it. Let's see, do we have anyone in yet? Let's try to get at least 5 players. Anyone joining in? Bueller. We got 1. It's gonna be very interesting. Let's see. It is 4:01 right now. I was getting ready and I was like, let's take a look over here. Got 1. William, do you have any questions about the test? What are you thinking? What are you thinking? Test-wise, getting ready-wise. Loading everything up over here. What questions do you have? Want me to look at some R output? Oh, we got 2. If you're 201, you could join in. You could win. You never know. It'd be crazy if you beat the 327 students. But you might have a head-to-head competition between Proud Starfish and Noble Goose 87. Prep, but going over the R output in class. Thank you, Sully. That really makes me appreciate it. I like when people say it's helpful. And also you get to understand what the test is kind of like. I'll post more to Discord too. Sorry, I posted to the 320 channel. I meant to post to 327. I wonder if, let me post in the Stat1 thing and say hey, you have a 201er wins, which I don't know if they would. I'll say if you want to try to win against BAS 27 students in their Kahoot, you can join in now. Okay, that's not the thing. I'll be like, it's just for fun. And then we'll get started here in a moment. At Stat201. Say, you can still win first. Win prizes. This is just for fun, though. Okay. We're going to give it just a moment right here. There's me looking down while I'm getting things ready. And so... in just a moment. Any questions in the chat? I posted to the... I'll put the thing bigger on the screen. Any questions in the chat as we see if any 201ers join in? Any questions? I could post in the 320 general too. Well, we'll give it 1 minute here. How's everyone's day going? Having a good day, William? I look so tired. Oh. I went to bed at... I was watching a video last night. I was watching a thing on Simpsons Hit and Run by Easy Speedruns or something. And then I was watching that and I just passed out. I was like laying on the ground watching it. I was just like, you ever just... That's like a classic thing to do. Like when you're a kid, you're just like, I'm gonna let her watch this video. And then you go, fall asleep. So good so far. I got in from Penn State last... Wow, Penn State is pretty far. Pretty far. Mubot says good morning. January says good. So yeah, well, I'm glad you're able to drive in and be safe. Get some good sleep tonight. Rest up. Well, we got 15 seconds. We lost a player though. I wonder who the other player is. So William, you're going head to head here for a gift card. Head to head competition. See who wins. I'll try to make sure you know what's on the test. Like once again, Kahoot's a little bit different, but we're gonna start up here in about 10 seconds. So let's get to it. You ready? Here we go. 3, 2, 1. Let's Kahoot. Smaller class, smaller Kahoots. So once again, you have written questions on the test, but these are kind of seeing if you know what this output is and know how to analyze it. State your conclusion on the QQ plot. So you should know what a quantile plot is and what it tries to tell us. So you can see any of these on the test. And there's only 2 possible answers. Don't worry if you got it wrong. When you analyze a quantile plot, we are looking to see if the data follows the what or doesn't follow the what. I'm going to pull up RStudio here. What is the point of a quantile plot? Don't worry if you got it right or wrong. What is the point of a quantile plot? To see if the data follows the what? What is the point of a quantile plot? The whole point of a quantile plot is to see if data follows the normal. So I'm going to pull up library reg class right here and do a QQ plot of random normal. Yep, follows the normal distribution. And this follows the normal, even if it has a weird issue or two. This is random normal data. That's like really, really normal. That's still normal. Every one of these is built from the normal. So if you see small weird things, that's not bad. We do want it to follow the line, but the line is the normal. So the line is telling us that the values here of -2 match up with -2 here. The -1 here matches with -1. So when it follows the line, the points are lining up with what is expected given normal. And once again, you might say, well, that deviates at the end of it. It's actually being generated from random normal data. So this is all actually coming from normal data. It's just slight weirdness. Like that's super duper normal, even if you have a weird point down here. Now, what you don't want to see, and we'll cover this more in a second, or not don't, but this is not normal data. And you look at all the deviations that none of these points follow the line. Like, see how this one mostly has points within the kind of, I call these the meh lines where it should be between. All but 1 point is outside of it. And then like you see tons of points outside of here, tons of points outside here, an extreme outlier over here. I don't even think that's as bad as it gets because yeah, you look over here, you got tons of points outside there. You got all the points outside here. That's not like where we just had 1 point outside. So yeah. So the more it follows the line, the more normal it is. And you want to be kind of nice to it. Think about grading it from an A to an F scale, where this would be something like a B+, and then this would be like a D- or an F. Like it's very bad. This is very not following the normal. If you look at the data this would come from, it would come from a very skewed to the right histogram, where the other ones would come from. So here's the other one. This comes from, I know I am regenerating this each time, but this comes from normal data, which can have some aberrations when you have data sample sizes. So the point of this is a QQ plot to analyze normality, and this definitely follows the normal for the most part. It's got a little bit of weirdness, but follows the normal. Proud Starfish Bull Kitten, good to see you. Don't worry if you got it wrong, but let's do the next question. Here we go. Side-by-side bots must compare a categorical Y and quantitative X. So what would you compare with this here? We'll look at this output. What would you compare with this? You get this right here. What are you going to compare? This is your graphic. What are you going to compare? It's a building upon the last question we just did. And we talked about this a lot in class. Don't worry about being wrong. Just take a guess. The more you do these, the more you know. Woo! Oh, we didn't get it. Well, the whole point of this, don't worry if you didn't get it. Let's take a look down here. So the output we usually see, and let's load up one of our surveys. We got to load up library. Oh, I did library. Data. Survey 11. And please drop any questions in the chat if you have them. So here we are with survey 11. Let's compare gender on height. And so we go association of x03.height with x02.gender. Data equals survey 11. And there we go. So if you look at the QQ plots for normality, this one is more normal than the other. It's got some outliers there. Maybe we should do weight. Let's do x04 weight. Yeah, because this one really has some what to it. Looking at these side-by-side QQ plots, there really is a lot of what to this data. What am I noticing over here? What am I noticing over here? There really is a lot of what. Looking at these side-by-side QQ plots, there really is. Remember, this is the normal right here. Like, this is the normal. That is the normal. There's values that are way higher, right? There's a bunch of whatses. There's a bunch of whatses, which you also see over here in the histograms. There's a bunch of outliers. Yeah. That's what's. Those are connected right there. Like that part of the graphic translates to that. There's good to see you, Andrew Wind. Andrew Wind, good to see you. Love seeing you, Chad. Good to see you. Hope you're doing well. Let me throw you 5,000 points right here for being here. There's a bunch of outliers, bunch of unusual things going on. Extreme right skew in the data. Javante, good to see you in the chat too. And so there is skew, there's outliers. So when we look at these graphics and we have two groups, we often want to compare the what's or what's of the two groups. And you can actually see it in the output. We want to compare the what's or the what's of the two groups. So you have two groups. Actually, it'll look better if I raise this up. You have two groups, and you often want to compare the what's or the what's of the two groups. Any ideas? And because of the skew over here, does that make sense? Who follows me on this? Does that make sense? Because of the skew, and outliers. You get skew, outliers, there's outliers there. That's all telling us we need to compare medians. So the practical significance difference here is a difference of 40 seen between these two numbers that typically males weigh about 40 more pounds than females typically. And this is a very statistically significant difference right here. Do you follow me on that interpretation and what we're looking for in this output? This p-value is figured out by doing the permutation procedure down here. And that's how the p-value is calculated by the area to the right of there, which is nothing. So, yep. So understanding this output is important, and knowing that we make decisions on comparing means versus medians based on the shape of the data and does it follow the normal. This one doesn't. It's got aberrations there. It's got this weird bend to it. It doesn't really follow the line very well. So we would compare medians due to not following the line. There we go. No one got it, but that's all right. Next question. Here we go. How do we interpret the intercept? How do we? We'll do an interpretation of intercept here in a moment. Which one is it? Little tricky. You probably want to mention if it's logical or not. Oh, no. Among individuals with x equal to 0, we expect y to equal b0. So that's just practice. Remember, you can take notes. So when you look for the intercept right here, we need to make a linear model. And let's change this to m, save into lm. And we need a linear model right here, x03 dot height. And let's go to summary of the model. And what is the intercept value? Just what is it numerically? Can anyone tell me the value of the intercept? What is the value of the intercept here? What is the value of the intercept? What is it? Anyone know? What is the value of the intercept? Thoughts on it? Just find the intercept. Who knows? Drop it in the chat for 1,000 points. What is the value of the intercept? I'm trying to see where that's at. That's a t value. So this right here is B0. That's all right. 1,000 points. Good guess right there. That is the intercept right here. This is the estimate of the intercept. So if we were to write the line, we'd write the line by doing the following. The line is going to be predicted weight. So predicted weight is equal to negative 161. I'm just going to round it. Plus 4.6 times height. So what does this negative 161 mean? It would mean, think about what the intercept means. The intercept is the value when, and actually it's negative, so we got to do this. It's the value when height is equal to 0. So if height is equal to 0, somebody is predicted to weigh negative 161 pounds. Does that make sense? If height is equal to 0, which because height is x, then someone is predicted to have a weight of negative 161. This is both illogical because you can't have a height of 0, and also you can't have a negative weight. So you'd be predicted to something that doesn't exist. So because people who have a height of 0 don't exist, so this model is going outside its range of values, and we even see that in the graphic that down here. So the question could be on the test, like, explain to your boss why the intercept has no practical interpretation right here by interpreting it and going through why multiple ways it's illogical. It's illogical because you can't have a negative weight. Negative 161 is an illogical value. It's illogical because you can't have a height of 0. That's an illogical value of height. We can also see by the scope, kind of the range of the x values here, that height doesn't go all the way to 0. So that would be the interpretation for individuals that have a height of equal to 0. We would expect their weight to be negative 161. Yeah, good stuff right there. Okay, remember you can write down all these interpretations on your piece of paper to know how to do it. Let's go to the next leaderboard. Proud Starfish. Let's do the next question. How do we interpret the slope? Be very careful. Who knows? Take guesses or what you got. Remember, you can write these down. So if you see this afterwards, write it down. I should put will on here. Will is a very bad word. Oh no. Where did we go? Seeing where the answers went. So two individuals who differ by 1 unit of x are expected to differ by b1 units of y. Let's take a look. So here we are. What is the value of the intercept here? Just tell me mathematically, what is the value of the intercept? I mean, the value of the slope. The value of the slope. I said intercept, but I meant to say slope. What is the value of the slope? Mathematically, what is the value of the slope? What is the value? Oh, that's all right. This is practice. This is a good time to get the answers wrong to get them right on the test. 1,000 points right there. Don't worry. What is the value of the slope? What is the mathematical value of the slope? Just take a guess. Don't worry if you're right or wrong. What is the mathematical value of the slope? I'll say it in a second. Yep, you got it. Nice job. That's 5,000 right there. There it is right there. There's the mathematical value of the slope. Remember, it's down here with the estimate of the slope. You kind of like pinpoint it in, estimate of the slope. So that's the estimate of the slope right there. With that being the estimate of the slope, it would be what? How do we interpret it? It'd be two people who differ in their height by 1 inch are expected to differ in their weight by 4.6 pounds. So you could say Brian and his wife differ in their height by 6 inches. So if you went here and did 6 times this right here, my wife is expected to differ in my weight. My wife is expected to have a different weight by me by 28 pounds or so, where my wife is expected to weigh less. Not that she will, she does, but she's expected to weigh less according to this model. Two people who differ by 1 inch in their height are expected to differ by 4.655 pounds in their weight, where the person who weighs more is expected, or the person who is taller is expected to weigh more. Does that make sense? It's not about that if you gain height, you will weigh more. It's that two people who differ. And there's people who break the trend, like this person over here. And this person, the person who is shorter weighs more than the person who is taller, because taller would go this way and weighs heavier would go this way up on this axis. So good stuff, good interpretations. Let's see leaderboard. We got another person, Amazing Campbell. Good to see you here. Let's do the question. What words describe this scatter plot? Ooh. What words? That's tricky. If it's multiple guess, well, I know it's a few. Okay, I got 2. I think it's 3 words. Yes, 3 words. I am between. I should have looked. It's iffy on the third one. If you get the third one, good job on you. I think I see it. I know what I'm going for. I'm going for heteroskedastic. It's everything but homoskedastic. Yep, everything but homoskedastic. I looked over the Kahoot and I didn't look over all the answers on this one because I was like, okay, this is the Kahoot I want because I made a lot of. I've made like 50 Kahoots. It's what does homoskedastic mean? Homo means same. And skedasticity means spread. So the way to check, like when you think about monotonic, you have to think about your favorite band. What does monotonic mean? Does anyone want to say in the chat? Drop what monotonic means. The way to memorize monotonic. It's your favorite band, remember? You gotta think what your favorite band is. It's not Blackpink. I'll tell you that much. So monotonic means one direction. So does it go in one direction? Non-monotonic would be 2 directions or more than one direction. So maybe it does mean unchanged or something like that. I always think one direction. So does it go mono meaning one and tonic meaning direction? Does it go in one direction? When you think about nonlinear, this does go in a non-line pattern, so it follows a nonlinear relationship. And then heteroskedastic meaning change in strength. Hetero means different, and skedasticity means spread. So if you look, it gets a little bit tighter as you go down. So it gets most tightest at the end, and that's a heteroskedastic. If it was homoskedastic, it would have about a similar strength throughout. It exhibits light heteroskedasticity. Like you can say things like light. This is very homoskedastic because the points have a similar type relationship. Extremely nonlinear, extremely heteros. This one has nonlinearity too and outliers. But extremely nonlinear, extremely heteroskedastic. We did it earlier. I could just load up what we did earlier because this will do it. Oh, wait. There we go. This is extremely nonlinear. You see it right here. There's the nonlinearity, the bend in it. And extremely heteroskedastic because it's extremely strong, even though the model's off. But it's a very tight relationship that goes to much, much weaker. So this is a very, very monotonic because it constantly goes up. It's extremely heteroskedastic because it starts out very strong and goes to weaker. It's extremely nonlinear because it's very flat and then it bends upward. Does that make sense, William, on the words like heteroskedastic versus homoskedastic? Linear, I think everyone knows linear versus nonlinear. And then also monotonic versus non-monotonic. Very important words to know and know what they mean, where you could say this data, goes in one direction. Like this data goes up. That's monotonic. This data goes down. This data goes up and down. It's non-monotonic. So non-monotonic would be like parabolic data. So I could ask questions like that. You're like, does your boss think it has a monotonic relationship or not? You need to know the fancy words. They need to know how to not use the fancy words. Ooh, we got some higher leaderboard stuff. Proud Starfish Bowl Kid. Remember, we got gift card, $20, Amazon or Starbucks. Your choice. Email me if you win. Let's do the next question. Here we go. Which of the following best describes a residual? Which of the following best describes a residual? A tree outside got destroyed by the wind. Oh, man. I'm gonna go home and drink some coffee. A residual is actual minus predicted. Actual minus predicted. Residual wrap. Residual equals actual minus predicted. So when you think about a residual here, residuals relate to regression. And you've noticed these points over here at the far side of the model. You'd want all your residuals to be close to what? Like a really good model has residuals close to what value? Like, put it this way. The model is doing really good right here because the residuals are close to what? Closer to what than over here where they're doing horrible in the blue region. Like, that's horrible. I mean, it's horrible throughout mostly. Only in that yellow region is the model doing really well. The goal is that you don't miss by much, and that's what a residual is. Like, if I said guesstimate the residual here, it looks to be about, it's 0.17 or so. Why am I guesstimating 0.17? because the points are 0.17 above the model. So in the positive residual zone, you're above the model. In the negative residual zone, you're below the model. So all of these have a negative residual. All of these up here have a positive residual. And positive means you are higher than predicted. On your test, do you want a positive or negative residual? On the test, you want a positive or negative residual. What do you want on the test? What do you want on the test? Positive or negative? Very clearly, you want a what residual? Don't worry if you get it wrong. Wake up, Brian. Come on, man. Positive. You want to be higher than you're predicted. So if you have a positive residual, you're above here. You are higher than the predicted. The line is the prediction. The A is the actual. So this would be a residual of like 8 if you were predicted to make a 92. Oh my gosh. You actually made a 100 and you made a 92. You have a residual of 8 because you're 8 higher than you were predicted to be. So residual equals actual minus predicted. It's the difference between the two, and it's how much higher you were or lower than you were predicted to be. Let's do the leaderboard. Proud Starfish, great job. Next question, let's go. Select the typical miss and the variation explained. Can you get it? Okay, we need the typical miss the model makes and the variation explained. One of these is the typical miss. One of these is the variation explained. We went over this a good bit in class right here. This is miles per gallon of a car explained by weight. So I did this earlier today with output. I use the same examples a lot. Ugh. Okay, pretty good. Okay. So we got some of the answers. It looks like everyone got the R squared. The R squared is the percent of variation explained. So we'd say 75.28% of the variation in the miles per gallon of a car is explained by the weight of a car. Very clearly, this is the practical significance here. Blank percent of the variation in Y is explained by the variation in X. And the typical miss the model makes is known as the residual standard error. The residual standard error is the typical miss the model makes. So when we predict the car's miles per gallon, we're typically off by 3 miles per gallon. That doesn't mean we are off by it. It's like saying when, imagine this. When I work out, I typically do 5 sets. That doesn't mean I will do 5 sets. You might say, well, sometimes you do 4 sets. I say, yeah, I typically do 5. Sometimes you do 6 sets. I typically do 5. Sometimes, one time you did 8 sets. I typically do 5. So you think typically means on average off by. So when you see the model typically misses by 3, you're going to predict this car gets 25 miles per gallon. Well, maybe in the range of 20 to 30 or something. That's kind of 1.66 standard errors. So, you don't know. If you predict 25, you could be off by about 3. Not saying you are off by 3. You could be exactly right. You're typically off by. And maybe I'll show the visual here to show what it looks like to be typically off by that, because I did do this earlier. So we're predicting right here, because I constantly do the same things. If you look at this, especially right here, this is off by about -5. This one's off only about by +2. That one's off. I'm looking at the scale. You see how this is 5 units? So, excuse me. That's about 4 units above. That's about a unit below. But the typical miss, because you see that one's way off. That one's like 8 above the line. So if you look, it's like 8 units above. You have to kind of think about the unit differences. But usually these are about 3 above and below. Like you average the miss right here, a miss of 3, which is about the length of this-ish. The length of this is about 3 units, and that's about how we are typically away from the line. Like you look at an average miss. Some are very small, close to 0. Some are very large, close to like 7 or 8. But we're typically off by about 3. That's what a typical miss is, known as the residual standard error, also the root mean squared error, RMSE or residual standard error. There we go. Got more people on the leaderboard. Proud Starfish leading the way. Only a few more questions. Let's do this. Our estimated slope could be off by about how much? We haven't covered this much, but you should know it. So this is the uncertainty thing I talk about a lot. We were predicting the meat weight from the diameter of an abalone, those crazy sea creatures. They are like shell creatures, and you open them up and get the meat out of them, and you eat the meat if you're carnivore, pescatarian, sure. And with this right here, the slope is the diameter. One person got it, I like it. And we think of the standard errors as metrics of uncertainty. So anytime you hear standard error, you should think uncertainty. You should know everything in this output, every little bit. The biggest miss in the model comes from the residual right here, this max residual. We were off by 0.33 in the amount of meat weight we would get. So that point was under predicted. We got 0.33 more because it's a positive residual. That's the biggest residual. There is a low residual of not nearly as far away. It's about half the distance of that on the low side of negative 1.5 or 6, negative 1.6 below the model. The distance is the residual. The estimate of the intercept is B0. That is B0 right there. That is B1 right there. So these are the estimates right here related to those. Now, they could be off by the amount of uncertainty we have in them is the standard error of B1, the standard error. This is the uncertainty. So how uncertain are you in your estimate? And then we use that to take B0 divided by its standard error. It's the one right next to it. So you literally divide those numbers. And you also do B1 divided by its standard error to get the t-statistic. So you divide 1.09 divided by 0.015. And you can see that leads to 71. And then you plot those on a t-curve. And the further away it is from 0, the smaller the p-value. And if you look, these are extremely large t-statistics. And we get the p-values. Now, once again, check out class review. Please ask questions if you have it. But you should know these values. Some of them are more important than others, like the slope and the intercept. But I could quiz you over any of these values. But expect quizzes more on like slope, intercept, stuff like that. Significance of the model. Significance of the model is found right there and right there. Even though this value is the same, it's not the same p-value. It's actually a bigger p-value because it comes from a less extreme t. What else we should know? The r squared right there, 76.93% of the variation in meat weight is explained by the variation in diameter. When we predict how much meat weight we will get, we're usually off by about 0.05 in the meat weight, typically off by the RMSE. So know this output. How are we doing on this, Will? Anyone else in the chat? Know this output. Know this output. Significance codes are used for stars to tell you how significant something is. I think we went through at the end of one class and went through each thing in this output. So make sure you know every bit of this output as my screen just randomly blinks. 2 more questions to go. Let's do this. Proud Starfish in the lead. Next question. What is the significance of the model? We were just covering this a second ago. I love review questions. We didn't do every type of question here. I'll maybe do a mosaic plot. You're welcome. Glad it makes sense. What is the significance of this model? So actually, this is a bit of a trick question. I didn't intend it to be, but this is supposed to be statistical significance. Because I think if any of the other values could be argued. Okay, yeah. The answer is statistical significance, which is going to be this one. The statistical significance of the model is a p-value. P-value is statistical significance. I could see this 7694. That, well, firstly, I copied the number wrong. Whoops. The r squared is practical significance. So you could argue that. You could, if you say, I thought you meant practical significance. I don't think, is 0.05 on here? 0.05 is, you can argue that is practical significance too. 0.066 is, standard error doesn't have anything to do with significance. It's a calculation of uncertainty and an estimate of the intercept. Does not tell you any practical or, it's used to lead to the t-statistic, which is used to lead to the p-value of the intercept. So the intercept is not that important value. The slope is important. So the p-value is the significance of our model. Remember that output we just covered. This right here, as we were mentioning, the things in blue are the statistical significance of the model. That p-value up there is the same p-value down low. If you get a model that has a higher p-value than the very, very tiny one we found here, you'll be able to see that those two values are the same p-value. There we go. Okie dokie. Let's continue on. Proud Starfish, Bold Kitten, Amazing Camel, and Noble Goose. Good to see you here. Next question. What should we use? Dun, dun, dun. Now here's the answer. We haven't covered Spearmint, which I was fine with. It's a bit of a trick one at the end. Only trick one I've seen so far. Oh, everyone. Yeah, Pearson. It could, well, hey, I'm glad we ended that way. People got it right. I like that. Pearson is for linear relationships. One could argue Spearman could be used, but still, you can use Spearman, which it's not on the test. That's why I said a bit of a tricky question, but I left it on here because I was like Pearson. Spearman's for nonlinear but still monotonic relationships. Pearson must have linear. You have to know that if you see nonlinear relationships, you can't use Pearson. And we're going to cover more ways of handling it than Spearman rank correlation. We're going to cover some better techniques like nonlinear regression approaches. So I didn't include it because I wanted to get to the better approaches. So yeah, let's look at just a little bit of output, then we'll look at the leaderboard. You could show something here like, do you remember this output, Will? Boom. This is every single correlation in a data set. All of them. And here's the top 10. There's the top 10 strongest correlations in a data set. This is why we learn to work with data, because you can find strong correlations like that in your data. It's also a little bit cheating if you're collect a whole bunch of data and just find things on purpose, because then you didn't really do a hypothesis and see if, you know, if you just backworking the data a hypothesis, you're not making a risky prediction. And so it's kind of good science should make risky predictions and go out on limbs and say, you know, if my hypothesis is true, this is what I should see in the data, not backwork things in and figure out where lightning is striking. It's very, very interesting. I've been reading Karl Popper and stuff and philosophers on how science should work. And Rotowave bomb, 5,000 points, Rotowave here. 5,000 points, Rotowave. Good to see you. Always the Rotowave bomb's the best. 5,000 points in the chat. So this is the most statistically significant correlations. We'll look at, well, we did the side-by-side box flash. Javante. Yeah. Oh, Javante, I'm glad you've been here. W Rotowave. Yeah. So glad to see people in the chat. And let's go here and do association. Let's see if you're, if you grew up in the, if you're more likely to be in Greek life, if you grew up in the US. So I got to type it in, Greek, and x12 dot grew up in US. Data equals survey 11. The answer is grew up in US, not found. Grew up, what did I do wrong? Grow up in US. You know what we're gonna do? We're gonna make it work. Attached survey 11, x12. I probably missed a capital. X, oh, the capital X. Thank you, Rotowave. More points in the chat. I love former students swinging by. Yeah. This is as strong a relationship as we usually see. It is a little bit smaller of a data set. But if you look right here, and we did this in 201, we cover mosaic plots. People who did not grow up in the U.S., only about 10% of them joined Greek life, versus people who did grow up in the U.S., 31%. This 31% is the conditional distribution within here, showing that there is a difference of 21%, as in people are 3 times more likely, or 3.1 times more likely, 3.17 if we go very exact, 3.17 times more likely to join Greek life if they grew up in the U.S. versus did not grow up in the U.S. And this is an extremely statistically significant relationship, where we see the differences here between the yes grew up in the U.S. and the no did not grow up in the U.S. A very, very big difference between the percent of people who are in Greek life. So you would think if someone didn't grow up in the U.S., not saying it's just probability. It's saying, you know, you think Brian grew up in the U.S., I guess he was in Greek life. Nope. Didn't join Greek life. My brother did. I didn't. Yeah, doesn't mean you will or must. It's just trends in the data and what is likely or unlikely given what we see relationshiply. Of course, most people who grow up in the U.S. don't join Greek life. Yeah. Then what's the operational definition? Like, what is Greek life? How do we define Greek life? How do we define growing up in the U.S.? How do we define these things? It's operational definition. It gets into a lot of how do you organize your data? How do you collect your data? How do you validate your data? So it's all about data. Well, with that, any last questions right here? I'll disappear, but this is a quick mosaic plot with the contingency table with the observed counts. There's only 3 people in this group right here and 27 people in this group. Might try to beat the traffic home. But who won? Who won? Do you want to say if you won in the chat? Remember to email me if you won. We have a winner here. Top 3 on the podium is a small Kahoot. We still got points. Amazing Camel. 3rd place, good work. In 2nd place, Bold Kitten. And in 1st place, winning the Amazon or Starbucks gift card, you get to pick which one you want, is going to be Proud Starfish. Nice job, William. Well, William, you just won the Amazon or Starbucks gift card. Please email me to say which one you want. And yeah, really proud of you right there. Glad you played. It's just good practice. You get to see, hey, a win's a win. A W is a W. I'll take it. Nice. Solid effort. Practice. Get to hear what you know. Didn't. That's all right. Yeah, Andrew threw it. I like it. Andrew, so good to see you. Hope you're doing well. If you're ever on UT, let me know. I'm gonna try to beat the traffic home, I think. Yes. No, wait. Tomorrow's online. Tomorrow's online. I hope I've changed it to show that. I did have both. Tomorrow's online. It's online right after Stat 201. Because I was doing in person, and I thought it'd be better to do online so we can like show up. My hair just keeps looking weird. Yeah, hair just keep it back. So it is online tomorrow. With that, tomorrow right after Stat 201. So it's like Stat 201's 12:20. Wait, what time is Stat 201? Sounds good. Worst case, I will catch it. Awesome. Well, I will see you then. Bye for now, everyone. Bye.